Hi everybody, in this video I'm going through the solutions for our first diagnostic test for Term 1 Year 11 on arithmetic and geometric sequences. Okay, this first question just requires us to identify these sequences as arithmetic, geometric or neither. Remember, arithmetic sequences have a common difference, geometric sequences have a common ratio. That means arithmetic sequence are an additive pattern and geometric sequences use a multiplicative pattern. Okay, let's look at the first one. Okay, for this one here, firstly, I'm going to check it to see if it is an additive pattern, an arithmetic sequence. I'm going to say this one here, take away that one there. 9.6, take away 28.8, and I can see that that is negative 19.2. Now I'm going to say 3.2, take away 9.6. And that is negative 6.4. There is not a common difference there. It is not arithmetic. Next thing I'm going to do is check it to see if it's a geometric sequence. I'm going to say that one divided by that one. 9.6 divided by 28.8. And that is 1/3 or 0.33 recurring. Next thing I'm going to say is this one here divided by this one here. 3.2 divided by 9.6. Oh, look, and that is also a third. Now, that is the same. What we have here is a geometric sequence, and R is 1/3, or 0.3 recurring. Okay, now a lot of you in this one identified that it was a geometric sequence, but said that R was 3. R does not equal 3. Remember, the R value tells us what we are multiplying by to go from there to there. If we are multiplying by 3, 28.8 is going to go up to like 50 point something if we're multiplying by 3. No, we are dividing by 3, which is the same as multiplying by 1/3. So we are times 1/3 from there to there, times 1/3 from there to there. Okay, let's look at this next one here. Firstly, I'm going to check it to see if it's arithmetic. I'm going to say this one minus this one, 27.1 minus 30.5. And that gives me negative 3.4. Then I'm going to say this one here minus this one here, 23.7 minus 27.1, and that gives us also negative 3.4. This is an arithmetic sequence. And the common difference is negative 3.4. Now, some of you identified that as an arithmetic sequence and said that the difference is 3.4. No, when we're going from here to here, we're adding negative 3.4. So the difference is negative 3.4. If it was positive 3.4, each of our terms would be getting bigger, and they're not. Next one here, first thing I'm going to check it to see if it's an arithmetic sequence. I'm going to say this one minus this one. 20 minus 10 is equal to 10. Then I'm going to try this one. 40 minus 20 is equal to 20. They are not the same. I need not go any further. It is not arithmetic. Next thing I'm going to try is to see if it's geometric. I'll do this one in green. I'm going to say this divided by this. 20 divided by 10 is equal to 2. Ooh, this is looking good. Then I say 40 divided by 20 is also equal to 2. This is good, but I've got one more to check. Now I'm going to say 70 divided by 40. Does that equal 2? No, it equals 1.75. Pattern's ruined. It is not geometric either. It is neither. 1 mark each for those. In order to get the mark, you needed to correctly identify it and then also correctly identify the D or the R. Okay, this next question here was meant to be a simple question, but there were loads of problems with it. So we've got some sequences here. We've got to do these 4 things. Okay, so let's look at this sequence. Before we can do any of these 4 things here, what we're going to need to do is identify it as arithmetic or geometric. Okay, let's first try arithmetic. We're going to say this one minus this one. See what that is. 1536 minus 3072, negative 1536. Let's see if it's the same here. This one minus this one. 768 minus 1536 equals negative 768. They are not the same. I know straight away it is not arithmetic, so I can continue no further with that. Let's try for geometric. How do I do that? I'm going to say this one divided by this one, 1536 divided by 3072. 0.5, that's sounding hopeful. Then I'm going to say this one divided by this one. And that is also 0.5. So it is geometric, and R is 0.5. That's the common ratio. What that means is that going from term 1 to term 2, I'm multiplying by 0.5. Okay, let's go and now look at these questions. Now, this was the worst question done on the whole paper. Write the recursive function. Now, recursive function starts with term n plus 1 equals. Recursive function means that we're wanting to know how do we find the next one in the sequence. Well, the next one in the sequence, that's what that means, is the current one in the sequence times R, and R in this case is 0.5. That's what I'm looking for here. The next one in the sequence is the current one in the sequence times by R. You could also write that as 0.5 Tn if you like. Same thing. So that's what I'm looking for, one of them. The formula for the general term, well, we can go to our formula sheet for this. Formula for the general term starts with term n equals, term 1 r to the power of n minus 1. Now, that is just the formula from the formula sheet. We want the formula for the general term for this particular sequence. Here it is. Term n equals term 1, this one, 3072 times r, 0.5 to the power of n minus 1. That's what we're looking for, the formula for the general term. Now, term 14. Term 14 equals, I'm just going to use this formula that I've just written, 3072 times 0.5 to the 14 minus 1, which is the power of 13. Then type that into the calculator. And that gives me 0.375. Next, I'm just going to ask myself if that makes sense. Well, this is a halving pattern. And if I halve 14 times, I'm going to get down to a pretty small number. So that makes sense. Next thing I'm looking for, the sum of the first 10 terms. Now, we had some people for this one use the arithmetic sum formula. That's not how we do it. The sum of the first n terms equals term 1. Then we have a fraction here. On the top, we have r to the power of n, take away 1, over r, take away 1. Okay. Term 1, 3072, times fraction. And just do this in your calculator. R to the power of n, r is 0.5. We're after the sum of the first 10 terms. So 0.5 to the power of 10, take away 1, over r take away 1, 0.5 take away 1, and I'm just going to type that straight into my calculator. And that gives me 6138. Okay, so in terms of the marking for that, you can see where you went wrong. That there got you a mark, that one got you a mark, that got you a mark, that got you a mark. No part marks for those. Okay, let's come over to this next sequence. Firstly, we need to find out if it's arithmetic or geometric. Negative 11.6 minus 15.3. So I can see going from here to here, I'm adding 3.7. Next, I'm going to check if it's the same here. I say minus that, minus that. I'm not going to muck up my negatives. That's just what I'm going to type in. Negative 7.9 minus 11.6. And that's going to give me also 3.7. So what we have here is an arithmetic sequence with the common difference of 3.7. So first thing we need here is we need the recursive formula. The next one in the sequence is the current one in the sequence plus the difference, and the difference is 3.7. Next, the general term. term n is equal to term 1, this one here, negative 15.3, plus n minus 1, lots of the difference, and I'm going to put that difference there because then when I go through to multiply that out, it will be easier. Okay, now some people leave it there, and I'm absolutely fine with you leaving it there. Some people like to expand this out to make it look prettier, and that's going to be 3.7n minus 3.7, and then we could collect like terms here if you want. Minus 15.3 minus 3.7, negative 19 plus 3.7n. Do it like that if you like. I'm perfectly fine with that, but if you want to follow it through, sure. Okay, next thing we're after is term 14. I'm just going to use this one here. Term 14 is term 1 plus the difference times n minus 1, term 14. 14 minus 1 is 13. Just type that in my calculator. And I get 32.8. Next, I'm after the sum of the first 10 terms. I go to my formula sheet and I say that's going to be n over 2, 2 lots of term 1 plus n minus 1 lots of the difference. So n is 10, 10 divided by 2 is 5, 2 lots of term 1, which is negative 15.3, plus n minus 1, well n is 10, 10 minus 1 is 9 lots of the difference, which is 3.7. And I'm just going to type that in my calculator just like that. And that gives me 13.5. Again, for that one, marking, how do we mark this? I'll do the marks here in blue. 1 mark for that, 1 mark for that, 1 for there, 1 for there. Now, this is all simple, familiar stuff. There's no part marks for any of this. You need to be able to correctly use these formulas. Okay, this next question, I note first that I've got an arithmetic sequence. And I know term 10 and term 13. And I want to find the common difference, D, and term 1. Well, because 10 and 13 are pretty close together, I'm just going to do it like this. This one's term 10, term 11, term 12, term 13. How do I go from term 10 to term 11 in an arithmetic sequence? I'm adding the difference. How do I go from that one to that one? I'm adding the difference, that one to that one, and I'm adding the difference. Now I know that that one there is 14.8 and this one here is 35.2. So I've got 14.8 plus D plus D plus D equals 35.2. 14.8 plus 3 lots of the difference will give me 35.2. And then from there, I can just turn this around and solve it. 3 lots of the difference, 35.2 minus 14.8. Which is 3 lots of the difference is 20.4 divided by 3 divided by 3. The difference is 6.8. Now, have I finished yet? No. What am I after? I'm after the common difference. Got that. And term 1. Well, I know that term n is equal to term 1 plus n minus 1 lots of the difference. Well, I know that term 10, let's do it. Term 10 is 14.8. So we're looking here at term 10. It's 14.8. That there is going to be our n, isn't it? Is equal to term 1, which I don't know, plus n minus 1. 10 minus 1 is 9. Lots of the difference, which is 6.8. Work that bit out on my calculator. 61.2. So term 1 is going to equal this one, 14.8 minus this one, 61.2, which gives me negative 46.4. There's different ways to solve that, but overall I think that question was quite well done. In terms of the marks, we said 3 marks for that. I think 1 mark for some kind of process here. Different ways of doing that. Mark for that, mark for that. Okay, this is probably the question on the paper which was the most badly done. So let's have a look. First up, we've got a geometric sequence, and we're given term 4 and term 6. Watch how I'd set this up. We've got term 4, term 5, and term 6. Term 4, 62.5. Term 6, 390.625. Find the possible values. Now that word there is key, possible values. There could be more than one. Now, how do I go in a geometric sequence from one term to the next? I'm multiplying by r. And then I'm multiplying by r here again. So I get myself a little equation. 62.5 times r, so it's going to be times r squared, is equal to 390.625. Divide both sides by 62.5. And I get r squared is equal to 6.25. Now, this is where people went wrong. Let's just take an easier number. If r squared equals 9, what will r be? Well, there's 2 options. Square root of 9 is 3, so r could be 3, but it could also be negative 3. Negative 3 times negative 3 is positive 9, isn't it? So here, if I've got r squared equals 6.25, r is equal to plus or minus the square root of 6.25. So we've got 2 options here. Square root of 6.25 is 2.5. We've got r is 2.5, but we've also got r is negative 2.5, and these are both absolutely valid solutions. Now I've got to take them in turn. Let's look firstly if r is equal to 2.5. That's r. We need term 1. Well, term n is equal to term 1 times r, which is 2.5, to the power of n minus 1. That's our formula from the formula sheet. So let's use this one here. Term 4, 62.5, is equal to term 1 times 2.5, that's term 4, to the power of 3, which gives me term 1 is equal to 62.5 divided by 2.5 to the power of 3, which gives me term 1 is 2.5 to the power of 3. There we are. Term 1 is equal to 4. Now, that is one pair of solutions. That one and that one match. The next solution, however, we've got if r is equal to negative 2.5, then 62.5 is equal to term 1 times negative 2.5 to the power of 3. Okay, so term 1 is going to equal 62.5 divided by negative 2.5 to the power of 3, which will give us negative 4. So we've got our second solution here is this one. R is negative 2.5 and term 1 is negative 4. So to get the 3 marks, you needed to have both of those solutions. Now, because if we're just going this positive solution, really that's no challenge at all. That only got you 1 mark if you just got that. To get all 3 marks, you needed to get both solutions. Okay, question 5. I expected this to be an easy question, but we had lots of nonsense coming out in this. Okay, if we've got a D here, what kind of sequence is this? This is an arithmetic sequence. And can we find the sum to infinity of an arithmetic sequence? No, we cannot. Okay, an arithmetic sequence just goes on forever, either in that direction or in that direction. In any case, we cannot find its sum to infinity. So that's a definite no. Okay, the next one. We've got term 1, we've got an R, so we have a geometric sequence. We've got geometric sequence, so that's good. But you'll know on your formula sheet, sum to infinity equals term 1 over 1 minus r, but then there's this thing here that says the absolute value of r, or the magnitude of r, needs to be smaller than 1. So what this means, I imagine a number line, we've got 0 here, -1 here, 1 here. What that means is this magnitude sign means the distance that our r is from 0 needs to be smaller than 1. So it needs to be somewhere in here. The r needs to be within 1 step from 0, which is from -1 to 1, not including -1 or 1. Okay, now here we've got r is -2 over here. Can we find the sum to infinity? No, we cannot. And we had loads of people tripped up for that. We had people putting this into the formula and getting an answer that really made no sense at all. If we're finding the sum to infinity, we have to check that this r value is somewhere between -1 and 1. If it isn't, we cannot find the sum to infinity. Okay, the next one was done okay. Well, it's got an r, so it's geometric, so that is a good thing. Now we have to check where r is. If we've got -1, 0, 1, where is r? -1/2, that's fine. Okay, so yes, we can find the sum to infinity, and the sum to infinity is equal to term 1, which is 50, over 1 minus r. And here's where we started to go wrong. 1 minus -1/2. Okay, let's think about what that means. 50 over minus together, what does that make? Makes positive. 1 plus 1/2. 1 plus 1/2, 1.5, 1.5. Now, if in doubt, just type that into your calculator just like that, and it will give you the correct answer, which is 33 1/3, or 33.3, or an improper fraction there, whatever you like. Okay, they were worth, what does we say, 1 mark for saying no, 1 mark for saying no, and 2 marks for this one. Okay, next question here. Determine the value of x given that these three things are consecutive terms. Consecutive means next door to one another. Consecutive terms in an arithmetic sequence. Okay, so we've got an arithmetic sequence. We've got that, that, and that. X, let's clear up this pen. X minus 2, 2x minus 3, x plus 10. Okay, if we have got an arithmetic sequence, then this one minus this one is equal to this one minus this one. Let's do that again. We have this one here minus this one here. Let's write that down. 2x minus 3 minus x minus 2. This one minus this one. Now remember, put brackets around that one, is equal to this one here minus this one here, because there's a common difference between both of them. Okay, don't forget the brackets. Okay, now the most problems actually happen in the next line, which is expanding this out. We've got 2x minus 3 minus x, and then minus is a positive, plus 2, x plus 10 minus 2x, again minus, plus 3. Then we collect like terms here. 2x minus x gives me x. Minus 3 plus 2 gives me -1. X minus 2x, negative x, plus 10 plus 3, plus 13. Okay, send that one over the other side. It's going to be x plus another x, that's 2x. 13, send that over the side. Plus 1 is 14, so we have x is equal to 7. Okay, now determine the value of x. We're done. That's what the question asks. So what I'm going to do now is just check on this to make sure I'm right. If x is 7, the first term, 7 minus 2 will be 5. If x is 7, 2 7s are 14. 14 minus 3 will be 11. X is 7, that one's going to be 17. Let's check, what am I doing here? I'm adding 6. What am I doing here? Adding 6. Great. I know that I'm right there. So that one there was worth 3 marks. Okay, this one here, not well done at all. First thing I notice here is that I've got a geometric sequence. So I've got a geometric sequence and I'm beginning with these 3 terms. 1 term, 2 terms, another term. A minus 6, 2a minus 4, 6a plus 4. Okay, and I've got to find term 10. Well, if it's a geometric sequence, so we've got a common ratio between. Now, with the last one, when we had an arithmetic sequence, we said this one minus this one is equal to this one minus this one. This is geometric. So we've got this one divided by this one is equal to this one divided by that one. Okay, now we had some people getting that wrong from the start and treating it as an arithmetic sequence, which really doesn't work. We've got 2a over minus 4 over a minus 6, that's this one, divided by this one, is equal to this one divided by that one. 6a plus 4 over 2a minus 4. Okay, when we've got a fraction equals a fraction, we cross multiply. That times that equals that times that. So we've got 2a minus 4 times 2a minus 4 equals 6a plus 4 times a minus 6. Now, at this point, we started to see all sorts of nonsense. I had people here expanding this, saying that's, 4a squared plus 16. No, it really isn't. We need to multiply everything by everything. Do the FOIL thing right. This is going to be 4a squared first. Outside, that one times that one, minus 8a inside, minus 8a, next one, plus 16. This one over here, same thing here. 6a squared minus 36a plus 4a minus 24. Clean up both sides. 4a squared minus 16a plus 16. 6a squared minus 32a minus 24. Okay, we need to move everything over to the right-hand side. I've got 6a here, minus 4 here. Bring that over as negative. It's going to be 2a squared minus 32a plus 16. Minus 32 plus 16 is going to give me negative 16a, minus 24 here, minus 16 equals negative 40. Now I notice they're all even, so I'm just going to divide both sides by 2 just to make my numbers smaller and make it faster. How do I solve something where I've got a squareds and a's in the same equation? I need to factorise. I think that's going to be 5 fours, not 5 fours, 10 twos are 20. One of them's going to be negative. Negative multiplying here. Negative 10a plus 2a will give me negative 8a. So I've got a minus 10, lots of a plus 2 is equal to 0. So using the null factor law, we have a is equal to 10 or a is equal to negative 2. Let's take our first case here, and that is that a is equal to 10. If a equals 10, what does our sequence look like? Well, the first one is going to be a minus 6. 10 minus 6 is 4. Next one's here, 2a minus 4. 20 minus 4 is 16. 6a, 60 plus 4 is 64. And we can just work out, we've got a times 4 pattern. So we're after term 10. It's going to be equal to term 1 times r to the power of 10 minus 1 is 9. 4 times 4 to the power of 9, which will give us 1048576. That's our first solution. But we've got another solution, and that's this one here, if a is negative 2. If a is equal to negative 2, we've got minus 2 minus 6, which is minus 8. 2a, that's minus 4 is minus 8. 6a minus 12 plus 4 is also minus 8. So in this case, r is 1. Every single term in the sequence is the same. So term 10 is also going to be negative 8. Now, for that one there, we need all of that working. We need 2 solutions. So that's one I think you probably need to work through again because very few people got full marks for that. Okay, time for our word problems now. Mrs. Richardson is trying to run to keep fit. True story. Each month she is increasing her distance of her daily runs by 10%. Not quite true. During month 1, January, she runs for 4 kilometres each day. So that's going to be term 1 in the sequence is 4. How long will her daily runs be in July? Okay, so we're after January, February, March, April, May, June, July. We're after, this one here is July. We're after term 7. Now, if each month she is increasing the distance of her daily runs by 10%. Now, is this going to be arithmetic or geometric? This is where a lot of you went wrong for this. We're increasing each month by 10% of what the previous month was. So, runs in February are going to be the same as January plus an extra 10% of January. I say they're going to be 100% of January plus an extra 10% of January. Okay, 100% plus 10% is equal to 110%. So each month is 110% of the previous month. R here is 110%, which is equal to 1.1. Okay, so each time I am multiplying by 1.1 to get the next amount. So for February, it's 4 times 1.1, which is equal to 4.4 kilometres. Next one, I'm multiplying by 1.1 again, which is going to be 4.84. And you can see it's going to go up like that. So what we've got here is a geometric sequence. Term 1 is equal to 4, and R is equal to 1.1, and I'm after term 7. Term 7 equals term 1 times R to the n minus 1. 7 minus 1 is 6. 4 times 1.1 to the power of 6 is equal to 7.09 approximately. 7.09 kilometres. Thanks to the people who said that I was running like 6,000 kilometres in July. That would be impressive if that was true. This one here. Okay, second last question. We have an arithmetic sequence. Term 1 is 3 and S8. That means the sum of the first 8 terms is 164, and we've got to find term 3. Well, what we're going to do is our sum formula. Sum of the first n terms equals n over 2 lots of term 1 plus n minus 1 lots of the difference. So the sum of the first n terms, so let's go n equals 8, 164, 8 over 2 is 4, 2 lots of term 1, here's term 1, 2 lots of that is 6, plus n we know is 8, so n minus 1 is 7, lots of the difference. Okay, I could either expand out here, but I'm just going to divide both sides by 4. 164 divided by 4 is going to give me 41. 6 plus 7d, take 6 off both sides. 35 equals 7 lots of d, divide by 7. 35 divided by 7 is 5. So the difference is 5. Now I'm after term 3. If term 1, I could use a formula here, I could just say, if that is 3, adding 5, I'm just using a recursive form here. 3 plus 5 is 8, 8 plus 5 is 13. So the answer is term 3 equals 13. For that one, we awarded a mark for the answer, a mark for D, and a mark for your process through here. Final question. Stacey makes pretty hair clips. She's getting faster at making them. On her first day, she makes a certain number of hair clips. Now, as soon as you see that she makes a certain number, on her first day. That's going to be term 1 of the sequence, and I'm going to call it something. I'm going to call it X. On the first day, she makes a certain number, and each day after that, she increases the number of hair clips she makes by 15. Okay, so we've got a difference here. So each day she is making a difference of 15. She's making 15 more. This is an arithmetic sequence. And term 5 of the sequence is 85. We are after the total number of hair clips she makes in those 5 days. That's going to be the sum of the first 5 terms. Now to do that, I really need to find term 1. So I'm going to say term n equals term 1 plus n minus 1 lots of the difference, and I'm going to use this fact here. Term 5 is 85 equals term 1 plus n minus 1. 5 minus 1 is 4 lots of the difference. 4 lots of 15 is 60. Take 60 off both sides. 85 minus 60 will give me 25. Term 1 is 25. Okay? Now, after that, I've just got to find the sum of the first 5 terms. Sum of n is n over 2 to term 1 plus n minus 1d. And I'm just going to feed it in there. 5 over 2, 2 lots of term 1. Term 1's 25, that's going to be 50. Plus 5 minus 1 is 4 lots of the difference. Pop all that in my calculator, just like that. And I can see that at the end of the 5th day, in those first 5 days, she's made 275 hair clips. And done. Okay, I suggest that you work through this video. After you've done that, try and do the whole paper by yourself again, see if you can get full marks. And then we've got another one that you can do and see if you can do that right.